All right, ladies and gentlemen, welcome to another day of dealing with vectors. And today, you may have noticed that there are these scary things. They're called matrices. Don't freak out, please. Please don't freak out. They're just matrices. You'll be okay. I promise. Just take a few deep breaths. I told you we were gonna have matrices again, and towards the end of the year, and here it is. We're gonna have some matrices today and tomorrow. Don't panic, please don't panic. Just take some deep breaths. You'll be able to handle this. You can use a calculator if you want to. Though this is not gonna be super helpful. But anyway, it might be helpful for this assignment, and you're definitely gonna need it for tomorrow's. So, step one, don't panic. All right, time for a quick recap because you're going to have to multiply a vector by a matrix, which is matrix multiplication. So a quick recap. To multiply two matrices together, you have to take the rows of the first matrix and you're going to times them by the columns of the second one. And so this matrix is going to get times by this one. And you're going to take this row and times by the first column, which is going to make -2 times 4 plus -5 times 2. So these two numbers times these two numbers, and you add those products together. Okay, that's the first thing. First row, first column. Now we're going to move on to the second column. Let's do this one in a different color. So we're going to do this row times this column. So you have to do -2 times -2 and -5 times -1. Okay, so we got -2 times -2 plus -5 times -1. Okay, and now we're going to move on to the next row. Let's move on to a new color too. So we got this row. Oh wait, there isn't a second row. And so, really, our problem's practically done. Because there is only one row in our first matrix, there is only one row in our answer. So go ahead and simplify these. You can get -8 plus -10, and then 4 plus 5, which will give you -18, and then 9. Okay? So, if you have a 1-row, 2-column matrix times a 2-row, 2-column matrix, you're going to end up with a 1-row, 2-column matrix. And it's going to come out to be -18, 9 here. So you're going to be doing this a lot in today's assignment. But luckily, if you look at your matrices, they have a whole lot of zeros and ones. And just a whole lot of zeros and ones. And sometimes there's threes instead. But a lot of zeros. And that makes calculations really nice. And eventually you'll get in a pattern of things and be able to do these really fast. So we're going to do a few of these. And you'll see what's going on. And so you're going to take this vector and you're going to times by this matrix, which to turn a vector into a matrix, all you do is change its brackets. And so it just looks like this. So this is our magical matrix, and we're going to be timesing by this matrix here, which, again, you're going to take this row and times by the column, and then times by that column, and you'll get your new matrix here. So -7, 5 times by -1, 0 gives you -7 times -1 plus 5 times 0. And now let's switch colors. Let's do this times this column. So it's going to be -7 times 0 plus 5 times -1. And if you go ahead and simplify those down, you're looking at, let's change it to green. You're looking at 7 and then -5. And we have this matrix. Well, this matrix is actually the same shape as this one, and we can turn it back into a vector just by changing the brackets and adding a comma back in. Oops, don't change it. We got 7, -5. Well, when you do this and you multiply that vector by that matrix, you change your vector a certain way. It changes into a different vector. It's been transformed. So our original vector was at -7, 5, and now it's at 7, -5. That's a transformation And if you just do a quick sketch, let's see, negative 7, 5 would have a vector here, and then 7, negative 5 puts the vector here. Hey, this vector went through a 180-degree rotation. That is what's happening on today's assignment. You're taking vectors and you're transforming them, as in rotating them or reflecting them or dilating them, and it's going to change it in that way. And so this is a 180-degree rotation. And just so you know, this matrix will always do that. You can take any vector you want, and if you times by this matrix, it will do a 180-degree rotation. So if you like having notes, you're the kind of person who likes having notes, you could write that down. This matrix rotates by 180 degrees. Let's try out another one. Same starting vector, but we're going to multiply it by a different matrix. This matrix is going to do a different transformation. So let's take this negative 7, 5 times by this. You're looking at negative 7 times 0 plus 5 times negative 1. And then we got this next column, negative 7 times 1 plus 5 times 0. If you go ahead and simplify that, you're looking at negative 5 and then negative 7. And you can turn that back into a vector by, well, changing the brackets and adding a comma. And now you can look at this starting vector and look at this resulting one after multiplying by that matrix and figure out what happened. If you want, you can draw a little sketch. Okay, we start out negative 7, 5, and now we're at negative 5, negative 7. Hey, that looks like a rotation as well. It rotated like that, right? If you count over 7, count over 5. And that is looking like a 90-degree counterclockwise rotation. And that's what it is. This is a 90-degree counterclockwise rotation. And this matrix will always do that. If you take any vector and times by this, it is going to rotate it 90 degrees counterclockwise. All right, well, what's going on with the rest of the assignment is building up that main idea. So what I recommend is you should go through the problems 1 through 6 and do those so you can see the matrices in action, and you'll kind of get a hang of what's going on as you start doing them. If you haven't done them, go ahead and do those. You'll see. All right, so let's jump to the next section. And we're going to, again, do some multiplying, and we'll see what happens. Well, this vector is getting times by this matrix here. And we got 9 times 4 plus negative 3 times 0. And then we got times by that next column. So it's going to be 9 times 0 plus negative 3 times negative 4. And that's going to yield 36, 12, which we can turn back into the vector 36, 12. Oh, sorry, other bracket. And ta-da! We figured out the new vector. Well, you may have noticed that these numbers got quite a bit bigger. You should figure out what number you multiplied both of your original vector numbers by. Right, you multiplied by 4. And look, in your matrix, there's a 4. So 9 got times by 4, and negative 3 got times by that negative 4. And what that does is that is a dilate by a factor of 4. But that's not the only thing that happened. The 9 got the same sign, but the negative 3 got a sign change when it got changed there. Well, if you switch from, hold on, draw a little sketch. You go from 9, negative 3 like this to 36, 12, which would be like that in comparison. It did have to get reflected over our x-axis. So it also has that built in. And so some matrices can do multiple transformations at once. This one dilates and it does a reflection. And that's because it has a sign change there. Well, in the next section, you need to figure out what matrix would yield this result here. And again, if you haven't done 1 through 6, do 1 through 6, and that will help you a lot. Because what's happening is you start with 2a and it would negative 8, 2. Well, that's like starting with xy and ending up with yx, and there's a sign change. I don't know if this looks familiar to you, hopefully it does, that this is a transformation that we did once upon a time in our transformations unit. And if you have that half sheet handy, you should go ahead and figure out which transformation that is. Right. It's a 90-degree counterclockwise rotation. Well, there is a matrix that does that. And guess what? We already saw it. It's number 2. This is a 90-degree counterclockwise rotation. And so this matrix that's going to make this happen is the same as this one. I told you earlier that this will take any vector and rotate it 90 degrees counterclockwise, and so that's our answer for this one. Oh, sorry. 0, 1, negative 1, 0. And voila, you got it. There's your matrix that's going to do the transformation you need. All right, we're going to do one more so you can see this in progress. So here, we're going from here to here. It's looking like 3 got times by something, get 27, and 9 got times by something, get negative 9. But they didn't get times by the same thing. All right, 3 times 9 gives you 27, but 9 times 9 doesn't give you 9. And so it's looking like this vector, xy, things got switched around like this. All right, if you switch them, now you're looking at 9 times something and then 3 times something. What do you times 3 by to get 9? And what do you times 9 by to get 27? That's going to be 3. And this has a different sign than this one. So you're going to add in a little negative there to our little function. Well, to get these times in by 3, your matrix has to do a dilate by a factor of 3. And it's looking like we got changing the order of our coordinates and a sign change on the x. Well, that's a 90-degree clockwise rotation. And so go ahead and look on the front for a matrix that does 90-degree clockwise rotation. And now you have, and go ahead and write down what that is. And once you have that, you're just going to take all the numbers and times by 3. So your numbers should have been 0, negative 1, 1, 0. And then you're going to times them by 3, which is going to turn this into 3, and this into 3. And voila, you have your matrix.